Here's page 9 of the notes, perpendicular bisector theorem. The perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Let's look at the perpendicular bisector. To make a perpendicular bisector, I need a compass. So I'm going to hold this so it does not move at the center A and make a circle. Then I use the same size, don't change the size, from center B to make another circle. So you see I have two circles, center A and center B, with the same radius. Now I can use a straight edge or a ruler to connect this point and this point. Then this line here is perpendicular to AB. Also, any point on this line is the same distance, for example, here, same distance from A as it is to B. This is the same as this, congruent. I can choose any other point. This point here is the same distance from A as it is to B. This line here and this line segment here is the same, or congruent. So what is AB? I have segment AC with a perpendicular bisector BD. So if it says that BD is a perpendicular bisector, then I know that this CB and AB are congruent. This measure is 77, so this one is also 77. What is CD? CD is here. I know that AD is congruent to CD, so 85 and 85, CD is 85. Here again I have a perpendicular bisector, it's perpendicular, and that means XW is congruent to VW, XY is congruent to Vy. It tells me VW, which is here, is 2t, Vy is 10, XW is 4t minus 8. XW, 4t minus 8. What is XY? XY is here. It's congruent to this length, so 10 is the answer. What is the value of t? Well, I know 4t minus 8 is equal to 2t because these two line segments are congruent. So 4t minus 8 equals 2t. Then I move t with t. So 4t minus 4t is 0. Then negative 8 comes down. 2t minus 4t is negative 2t. Then to eliminate negative 2, I divide. So negative 2 becomes 1, and I'm left with t equals negative 8 divided negative 2 is 4.